All right, guys, this lesson is going to feel a little like review, but you're going to be dealing with more complex expressions than you've dealt with in the past. So at the end of the lesson, you should be able to simplify rational expressions involving two or more variables. So rational meaning a fraction. So we've got some sort of ratio of one thing to another. We've got a fraction here. So it's a rational expression involving two or more variables, and you have to use the Gcf method to factor a polynomial of two or more variables. So we're going to talk about what the Gcf method is, but you guys should know, and maybe make a note of it right now, that the Gcf method just means greatest common factor. All right, so we're going to make sure we do both of these things in today's lesson. Let's start off with simplifying the following expressions. So A, we've got a fraction, and in our numerator, we have 26uv minus 39v. So we have two terms up there, and in our denominator, we only have one term. So what we really have here is 26uv divided by 13v minus 39v divided by 13v. So just to start, we should write that out just to remind ourselves that this is two different fractions being subtracted. That's exactly the same thing. And usually, if we have something like this, we would hope that we would simplify it and make it look like this. But in this case, I just want to remind you that this is what we're really dealing with. And at that point, we can just do some division, right? 26 divided by 13 is 2. uv divided by v, well, that's just going to be like doing v divided by v. So those two things will cancel. So you just have a u left minus 39 divided by v, or 39v divided by 13v. Well, 39 divided by 13 is 3, and v divided by v is 1. So that is the same as 2u minus 3, and we can't combine those because they're not like terms. So if I were to make some notes about this, I might mention the fact that I can separate these two things into the two fractions that we're really dealing with. I would also like to mention that when I divide uv by v, it's only the v divided by v that needs to happen. I don't need to try to force u to be divided by v. Remember, we're doing division, so the like terms thing isn't really an issue. Just because these aren't like terms doesn't mean I can't divide them. Let's use the same method on b. So b says 15x minus 25y over 5. So that's the same as 15x over 5 minus 25y over 5 minus, then we have 14x over 7 minus 21y over 7. And the reason that I put this all in parentheses is because we're subtracting this whole fraction, which means that negative applies to this fraction and this fraction. So if you don't put the parentheses, then this sign is not likely to be changed, and it needs to be. So let's start with our first fraction. We've got 15x divided by 5, that's 3x, minus 25y divided by 5, that's 5y, minus 14x divided by 7 is 2x, minus 21y divided by 7 is 3y. Now make sure we still have these parentheses because this is where we have to remember that that negative applies to all this stuff. So we really have a 3x minus 5y minus 2x plus 3y. And now we can combine like terms. So we have a 1x minus 2y. Okay, so a note that I might want to make to myself here over in the notes column is that if I'm subtracting an entire fraction, then I need to make sure that I put it in parentheses and distribute that negative, because this negative here applies to all of this stuff, not just this stuff. And that's a small mistake that people will continuously make. Now let's talk about using these skills to factor things. So we're going to use the Gcf method here. The Gcf method just means the greatest common factor. So we're going to find the largest number that goes into 8, 12, and 4. We're going to find the largest power of a that goes into a squared, a, and a. We're going to find the largest power of b and the largest power of c that I can remove from each of these terms. So 8, 12, and 4. All of these numbers have many factors, and I could list them all. I could say 12 has factors 12, 6, 4, 3, 2, 1. 8 has factors 8, 4, 2, 1. And 4 has factors 4, 2, and 1. All right, that's a good way to do it. So they all have a 1. They all have a 2. They don't all have 3s, can't use that. They do all have 4s, and then 4 is out of factors. So the largest number that is a factor of all of these is 4. So what we're going to do here is we're going to kind of reverse the process of FOIL. So we're going to have this giant expression in parentheses, and we're going to start pulling stuff out of it to factor it. So that's what we're doing here. One of the things we're going to pull out is going to be 4, because we've decided that 4 is the greatest common factor of 8, 12, and 4. And if I pull 4 out, that's the same as me dividing this by 4, dividing this by 4, and dividing this by 4. So I'll be left with a 2 here, I'll be left with a 3 here, and I'll be left with a 1 here. Notice I'm keeping the signs of these operations. Now let's do the same thing with A. All right, so we have 2 A's in the lead term, we have 1 in the second term, and 1 in the third term. So if we want to pull A's out of these terms, we can only really take 1 from each. So we'll have a 4A out front. And if I divided this by A, I'd be left with an A. If I divided that by A, we'd have no A's left. Divide that by A, no A's left, because A divided by A is 1. Same thing with B. With B, we've got 1 B in the first term, 2 in the second term, 3 in the third term. So I can only take 1, because they each do have 1 to give. So I have a B. If I divide this by B, that equals 1. If I divide this by B, that equals B. And if I divide B cubed by B, that equals B squared. And I do the same thing with C. I have 2 C's at least in each of these terms. So I can take a C squared, which is going to leave me with 1, 1, and a C. So my final answer, I could write that a little bit better, would be 4AB squared times 2A minus 3B plus B squared C. So essentially what we just did is we reversed the process of distribution. Normally when we see something like this, we try to distribute and make it look like that. We're factoring, so we're going the other direction and pulling that greatest common factor out. So let's do that one more time with D. In D, we have a 6, we have a 9, we have an 18. So our greatest common factor, if I list all these out, I'll eventually find that 3 is something that I could pull out of each of those numbers. So 3 comes out. Each one of these has a Q. They don't all have a P, and they don't all have an R. So I can only take a 3Q out of each of these. So if I divide each of these by 3Q, I'll be left with 2P plus 3R plus 6PR. And that's all you can do. You just reversed that process of distribution, and that's factoring. All right? So hopefully these notes help you out, and we'll do the practicing class tomorrow.